So this is what we have done till now. Okay, we have specified the capacitor value, compensation capacitor value, using this formula, this two formula. Okay, now let's keep this filtering capacitor value as 150 microfarad. Okay, and then what about this? Load should be calculated using this formula. Yeah, so this is what the equivalent resistance, which is the equivalent load. So its formula is 8 by pi square into R naught, and R naught is equals to V naught square by output power, which we are designing for the system. For what output power we are designing for the system, so that output power should be substitute here. Okay, so R naught is equals to V naught square by P. So V naught square here is the minimal nominal voltage which is present at the output. Assume that we are considering the output as in the form of batteries. So we are connecting 4 batteries, each one is of 12 volts. So we are connecting 4 in series. So at the output we will be getting the total voltage as 48 volts. So R naught can be calculated as V naught square, which is 48 square divided by P. So we are designing this system for 500 watts. Okay, so it is 4.608. Then as we want the equivalent load, so for that we are using the equation as 8 by pi square into on R naught is 4.06 equals to 3.29. okay, sorry, it is not 4.06, it is 4.6 equals to 3.72. so the equivalent load we are getting it as 3.7 ohms. Okay, so let's substitute here 3.7 volts. Okay, now we know that these two circuits are wirelessly connected, but how the system will get to know that these two circuits are connected internally, though they are not physically connected by means of wire, but they are connected through wirelessly. So how the system will get to know? For that we are using SPICE directive. From here, click on the SPICE directive and type capital K space L1 space L2 space what is the coupling coefficient we got in the answers. It is 0.22. okay, 0.22. place it here. So what this is indicating is that the two coils in the form of inductors, which is L1 and L2, are connected together at a coupling coefficient K, whose value is 0.22. okay, now let's apply the voltage. Move your cursor near the component and click right button in your mouse. This box will appear. Go in advanced. Now here we are selecting the pulse. The reason for selecting the pulse voltage, it is DC pulse voltage. Here, as I mentioned, that we have to use an inverter to connect it to convert our input. Either it will be in DC or AC. You have to fit it into inverter in order to increase the frequency of the current. So for that we are using here inverter. But in LT Spice you can directly use this pulse DC as your voltage instead of using the inverter. Okay, for that give the initial voltage as 220 volt minus 220 volt plus 220 volts. Keep the delay as 0, time rise as 0, time fall as 0. Let's move first to time period. So the time period is defined as the reciprocal of the frequency. we know that the frequency is 85 kilohertz. So take your calci and calculate for what is the value for 1 by 85,000. That is equals to 11.7 micro. Okay, 11.7 micro. So now what is t on? T on is the time for which you want your wave to be calculated. So for that we will be specifying it as 50% of the 11.7. okay, so 50% of 11.7 micro is 5.8 micro. Okay, 5.8 micro. That's done. Let's move our label to aside using this move option. Here we go. Now let's add ground to our socket. Take a wire from here. No. Okay, this is how it is done. Now click on run. Now for what time you want to run your simulation, you have to specify here. So I am specifying to run for 120 milliseconds. There you go, your simulations are running. Here we go. So first let us check that what is the input voltage. Yeah, see, here you can see that our input voltage is in the form of pulse. Though we are not able to see here, let's magnify it. Okay, this is what the means of pulse. Okay, plus 220 volts to minus 220 volts. Okay, now let's check what input we are getting. Okay, actually our result got magnified, due to which we are not able to see it. So let's close our simulation and run it again. See, we are designing for 500 and it is coming like approx to 500. Okay, okay, this is how it is getting.